Alright guys, welcome back. Today we're going to be looking at Unit 6's Embedded Assessment number 2 on page 633 through 635 on the PDF file of your book. My name is Coach Williams or Mr. Williams, and what I'm going to do is I'm actually going to work through the questions. Okay, so if you haven't had time to do that yet, I suggest that you go ahead and pause the video or log off the video and go do the questions and then come back. If you're stuck on a particular question, once I get to that, go ahead and stop the video and then move on to the other questions, because I really would like you to give it a try before you watch the answers. All right. That being said, we're going to go ahead in part 1 here. We're going to look at questions number 1 and 2, which equates to basically page 633. So I'm going to read through the questions, take time, hopefully explain where the answers come from, and hopefully they'll make sense for you. So we start out with Diane, who has a collection of 91 novels. They are categorized as shown in this table. This is detective novels. This is romance novels. This is other. This is our total. This is hardback. This is paperback, and this is our total. Just so you know where those numbers are coming from. They're copied directly from your PDF file. If Diane selects one of her novels at random, what is the probability that it is a romance novel? Okay, that's the first thing it asks for. So we'll use the correct notation, probability that it is a romance novel. Notice they don't give us any other information. They don't say it has to be hardback or paperback or anything. So we're looking at romance total, 36 over total number of books. So 36 over 91. Which comes out to approximately 40%. It's like 39.52 or something like that. We'll go with 0.40. Okay? The next thing they ask for is, what's the probability that it's a romance novel given it's a paperback? And so using the notation again, we're going to say probability that it's a romance novel given that it's a paperback. Okay? Remember we do the line and then talk about the given characteristics after that. So probability that it's a romance novel given it's paperback. So we look only at the paperback section. How many romance novels? 28. How many total paperbacks? 62. 28 out of 62 comes out to 0.45. Okay? Hopefully that makes sense. For B, for 1B, it says use the answers in parts A1 and A2 to decide whether the two events are independent. Explain your reasoning. So what they're asking is, as far as independent events, they're asking whether or not a book can be a romance novel independent of the fact whether or not it's paperback. Okay? And I'll just be really honest, the answer here is no. We know the answer is no because these don't match. Okay? Independent events say that the probability of an event, in this case that it's a romance novel, has to be equal to the probability that it's a romance novel given the other event, in this case paperback. And that is not true. So the answer is no. 0.4 does not equal 0.45. Okay? Hopefully that makes sense. If you're not sure, go back and double check the definition of what it means to be an independent event. Okay, let's look at number 2. Number 2, Diane is looking at her collection of ebooks. She has worked out that 60% of her ebooks were downloaded from Company A, 68% are works of fiction, and 36% are works of fiction that were downloaded from Company A. Yeah, we're good with that? When Diane selects one of her books at random, let the event that it was downloaded from Company A be A, and let the event that it's a work of fiction be F. So, this is my A, this is my F. The first step says, draw a Venn diagram to represent the information you have been given. Always be sure to write the probabilities in your diagram in your work as decimals, not percentages, so that's what we've done. I changed them over to decimals, and so A we've done, we'll go ahead and put a check. All right? For B, it says complete your Venn diagram by writing an additional relevant probability. So what we're going to go ahead and do is solve all the rest of the probabilities that could be there. Now you might be asking yourself, what's missing? Well, we're missing this value here, we're missing this value here, and this value here. All right? So let's start with the easy one. If this is 0.36 and this is 0.60, this has to be what's missing, so this is 0.24. Same idea here, 0.68, 0.36. What do you add to 0.36 to get 0.68 total, or what's 0.68 minus 0.36? You're going to get 0.32, all right? And then this missing value, we can do it several ways. You can do this one plus this one minus this one. That was our addition rule. I'm simply going to add these 3 across because that's going to give me my OR. And then the complement of my OR is going to give me what's outside, okay? And that's what's over here. So 24 plus 36 is 60, plus 32 is 92. So if I get 1 minus 0.92, I get 0.08. All right, hopefully that makes sense. So we've done B, check. C, When Diane selects one of her ebooks at random, what is the probability that it is neither a work of fiction nor was it downloaded from company A? So what we're looking for here is the probability of F or A complement, which is the 0.08. Okay, that's right here. That's neither one of them. All right, and that's one notation way to write it. The other way is probability of F complement and A complement. Okay, these are equivalent statements, FYI. All right, D. If Diane randomly selects a work of fiction, what is the probability that it's downloaded from company A? So now we're looking only at the fiction. Only at the fiction. So we're saying, what is the probability that it was downloaded from company A given that it's fiction? Okay, so the F goes second. And the way we're going to do that is we're going to do point. So these are the ones that are in A, so 0.36 out of all of F, which is 0.68. 0.36 over 0.68 is going to give us 0.53. So 53%. Okay. Let's go to E. If Diane randomly selects a book downloaded from company A, what is the probability that it is not a work of fiction? So we're looking only in A and not fiction. So probability of A and not fiction. Notice it doesn't say given that it's not fiction. It says A and not fiction. Okay? So there's a difference there. And sorry, I want to correct what I'm saying there. We're doing not fiction, given that it came from A. So I apologize. We are still similar to D there. So probability of FC given A. So we're going to go to A. A is this whole thing, this 0.6. So we're going to have 0.6 on bottom, or 0.60. And not fiction is at 0.24. So 0.24 over 0.6, you're going to get 0.40. All right. Hopefully that makes sense. Let's look at F. F says, hey, what are the values of PA, PF, and P of A and F? So let's just list those out real quick. P of A equals 0.6. P of F equals 0.68. And P says A and F, so P of A and F, which is, remember, the overlap, so 0.36. All right. G, use your answers in part E to decide whether or not A and F are independent. So we need to talk about what does it mean to be independent. Reminder, independent means just like kind of what we talked about in the beginning. So we would say P of A has to be equal to P of A given F. Now, P of A given F, and this is in your textbook from one of the earlier lessons, is equal to the probability of A and F divided by the probability of F. And we have that information, we just found it. So let's look at it. Let's substitute this right here. Let's change color so you can see it. Go to a different color. Let's take this value here and plug it into this relationship, okay, right here. And so let's look at what happens when we do that. When we do that, we're going to get something that we can actually verify is not equal. So theoretically, P of A versus P of A and F over P of F. If that's true, they're independent. Let's plug in the values and see whether or not it's true. So P of A is 0.6 equals to 0.36 over 0.68. That is not true, so not independent. Okay? Now, that might seem a little extra for you. You don't necessarily have to show that. If you can verify, if you can see the pattern, see that the probability of A is going to change, then that's okay. You can do that. But this is technically how you would show it. All right, you would show that this value right here, does not give you the same value as this, and therefore they are not independent. All right? So thanks for joining me. Come back to the next video. We'll look at number 3.